Hello everyone, welcome back to the Python Ethereum Explorer. Today we are going to take a look at a use case of Alice sending Bob a transaction, and we're going to do that, but we're going to show how the validation of the user and the transaction actually works. So if Alice sends Bob a transaction, Alice both needs to have her value of what she's sending validated, but as well as her address and the receiver address. So we're going to take a look at that real quick. We are using our code like before. Nothing's changed in here. We're just going to be using part 2 for here because that's where we use the nonce and we create the transaction. And that's just where this stuff occurs in the program or in the main file. So we're going to run the application as always in our VNV virtual environment. And so if we go back to the code, we can see, so Alice right here is going to be the sender. So we create her private key right here, which we can then go back to the output of the console and we see this the sender's private key because we set it as a variable. Now we enter the debugging stage of the code. And this is part 2, so this is going to have something to do with transactions. And this is the full process from when Alice sends Bob a transaction. So at the beginning, Alice's nonce will be 0 because she hasn't sent anything to Bob yet. It's thus her nonce hasn't increased because there's no transaction by her to Bob in the block right now. So that's stated as 0. We have unsigned transaction because even though this transaction has been committed to the chain or committed to the block, there is no verification or validation that Alice is an account and has the amount of ether or value that she can send to Bob. So we had to check that to make sure that the sender's real, the amount that they're trying to transfer is real, and then we can validate the transaction. And when we validate the transaction, it's called signing the transaction. And that signed transaction gets put into a block. But that's all we're taking a look at right now. How do we prove that Alice is Alice? And how do we verify that she has what she has? So if we come up here, we have her private key. So the private key is used in the code to create the V, the R, and the S, which we can see down here on the signed transaction part. So this gets run through function in the code to create the V, the R, the S. The V is the remainder, the S and the R are split of a cryptographic function to convert that. And this is what creates the signature. The signature essentially is the V, the R, and the S, which, as we can see from the unsigned transaction, once Alice has been validated, it will be the V, the R, the S will be added, saying that yes, these are the values for Alice, who's the sender, and yes, we've validated that she is an account and she does have the amount of ether she's trying to send. And the way that's done, it is through the consensus algorithm. So we are going to be looking at our target and our max. So our target should always be lower than our max. All of these work out here, but something really interesting to see is this is our max value of the block. And this is what we're comparing everything against. And so when we do the V, the R, the S, we can see that the S starts out 2241. And we can see right here, this is S. This is the value we're comparing to the block value right here. And if we look for R, we see it starts out with 3146. And we can see that here, 3146, and ends with 788, and we see 788 right here. Okay, cool. So that's 2 parts of the signature. Now we just got to find the V, which is down here. I do not know. I know this is the leftover data from the split of the R and the S, but I don't know why it compares V to itself. That's just something I don't know. I haven't figured that out in the code yet, but that's something I'm still working on. And we come down here, and this is the validation that she does have that amount. So she has this amount that she can send, and we're going to be sending that amount. And this is the block right here. So when it gets added, this is the resulting block hash compared to where this is the target hash, and this is the resulting block hash from the mining. So we can see that it is lower, thus forming the consensus. But so consensus gets met several times here in the validation of Alice as a user, as a sender, and the transaction that she sends. It gets run to verify her account amount, so the amount of ether she has. The validation process also validates that Alice is an account with a private key and with the address that she says it is, and the private key works with that address. If any of those were to fail, the transaction would not be signed, and we wouldn't be able to have a successful transaction. So that's just a little use case for an Alice and Bob example of how the transactions and the users in the Ethereum blockchain are validated via the consensus algorithm. So thank you very much for paying attention, and stay tuned.